All right. Hello, class. Okay, let's begin our lesson for today. Okay, what are we going to do today is that we are going to discuss our test of knowledge the other day. Remember last week I gave you all test of knowledge? Okay, as requested, some of you asked, teacher, can we discuss? Yes, for sure, we will discuss, and these are the correct answers. I am so proud of your marks, but I'm sure some of you just need a little bit of polishing. Okay, it's actually very simple. We start off very easy, then slowly our test knowledge will become harder and harder. Okay, so these test knowledge was covering topics 4.1, 4.2, and 4.3. This week we already learned 4.4 and 4.5, so sooner or later we'll have another test knowledge for that. Okay, let's start off. Let's start off by having a recap. Okay, class. In order for you to have force, weight, mass, what is the force that is so important that is responsible for all these forces? Okay, I give you a clue. This force pulls everything to the center of the earth. What can you think of? What's the name of the force, class? Okay, very good. It's gravity. Okay, before we begin our discussion, why not we start with a quick check, like a quick video on gravity and who found gravity and how did they found gravity? Right? You know, you keep hearing the word Newton, Newton. Do you know that's actually a person's name, which is a physicist, Isaac Newton? So let's watch this video. Okay, let me share my sound. Okay, have fun.
Hey friends, have you ever wondered what keeps us floating off into space? Why am I going down after every jump? Well, this is called gravity, an invisible force that pulls you back to the earth. Sir Isaac Newton, a well-known scientist, discovered gravity about 300 years ago. The story is that Newton saw an apple fall from a tree towards the ground. At first he thought, why didn't the apple go up? Then he realized that there was a force that made it fall on the ground, and he called it gravity. You'll be surprised to know that every object that has mass exerts a gravitational pull or force on every other body of mass. The size of the pull depends on the mass of the objects. This is how the sun's gravitational pull keeps planets orbiting around it. Even the Earth has a gravitational force on the moon. That is why the moon rotates around the Earth and does not float away. That's amazing, isn't it? An invisible force has so much to do with the way we live. Oops, I forgot to tell you that tides in the sea and oceans happen because of the gravitational pull of the moon. 1, 2, 3. By the way, have you ever thought why a stone falls on the ground faster than a piece of paper? That's because the bigger the object's mass, the more gravity it will have. And the smaller the mass of the object, the less will be the gravity. Trivia time! The moon's gravitational pull is 1/6 of Earth's gravitational pull. A person weighing 150 pounds on Earth would weigh no more than 25 pounds on the moon. Imagine how far you could jump on these two places. So next time, when you see high tides and objects falling on the ground, you will know why that happens. So this is me zooming out. Tune in next time for more fun facts.
Okay, I hope that was insightful. Okay, let's start off with our discussion. Can I go into full screen mode? Okay, now, number one, what is the unit for mass. Okay, class. The unit for mass, as I've already mentioned so many times, it's kilograms or grams. Or you can write in a longer form, kilograms or grams. Make sure, okay, this is a lot of people careless mistake. kg is both in small alphabets, not capital. Once you put K capital, it's automatically wrong. No marka kesian, no PT marks, okay? All right. Number 2, this is done. Number 2, what is the unit of weight? Okay. The unit for weight is N, or in this case, Newton. Okay. Number 3, what is the name of the force that makes objects fall on the earth? Okay, as Dr. Binos have mentioned, it is called gravity. And of course, now you know it is actually founded by Isaac Newton. Okay, those who got these 3 wrong for their test of knowledge, I want you to write in your exercise book for correction. Okay, write into your exercise book for correction. I will pause 1 minute for you to take note of any correct answers you want to do as correction. Okay. Okay, let's continue. Let me clear my screen. Okay, let's go. Okay, now figure 1 shows a table with different forces measured using a specific device. Okay, wait, before that, I think I need to zoom in a bit more. Yeah, I think this is better. Okay. Okay, figure 1 shows a table with different forces measured using a specific device. They never mention what device. Okay, that's a question for you to answer later. Now, pull, push, and twist. These are all 3 different forces. But do you know that you can actually measure them? But it's not using any type of scale that you can think of. It's like, those spring balance, no, that is to measure weight or mass. Okay, for like bathroom scales and kitchen scales, that is to measure mass. Okay, but what about pull, push, and twist? Okay, so based on figure 1, what's the name of the device that is used to measure the different forces above? The answer is force meter. Easy, simple, and precise. Force meter. Okay. Number 2, based on figure 1, what is the standard measurement unit for the force measured above? Okay, they never provided what's the unit, So you need to figure out what is the unit. When someone asks you what is the standard measurement unit, you must always keep in mind they are asking what is the unit. They won't ask, sure, what's the unit? They will keep it in a scientific, precise manner in which they will say standard measurement unit. So the answer is Newton or a capital N. Please write in capital N. Small n is wrong. Okay. I will wait 1 minute for those who want to take note of this. All right, let's continue. Okay. So now, figure 2 shows 5 different force meter with different number of blocks attached to each of them. Now, first things first. Okay, for this, I will zoom in a bit to show. Okay, first things first, don't get confused. You see here, the reading only begins from the top. Okay, from the top. Here is 0. Here is 10. That means the white part here is the actual reading, not the black part. So they are confusing you. When they put this black part, they make you think, oh, actually the reading will decrease if I put more blocks. If you ask yourself, now if you put more blocks, of course the reading will increase, doesn't it? So why so many of you got this wrong? Because you got confused with the black part. Okay, you thought that was the reading, but in actual reality, the white part is the reading. Okay, please get yourself checked out for this because this is a very bonus question. Because of this, so many of you didn't get marks. Okay, let's continue. Based on figure 2, what is the reading, okay, of the weight in force meter label D? Okay, so the reading is, you see the white part, it is 3 Newton or 3 capital N. Okay, this one. All right, okay. Next one. As the number of masses increases, the reading on the force meter, of course, it increases, class. You see here, right? Okay, let me just take an example. Let me take the lowest. The lowest is basically C and the biggest is A, right? You see the lowest of the readings are 2 Newton, but the highest is 10. Okay, so it should be obvious to you that as the mass of the blocks increases, of course the reading also increases. So many of you wrote decreases, I think, because you got confused with the black and the white part. Please make sure to check the question, read back your answer. Does it make sense to you? Then only submit. Okay, class, don't do this careless mistake in checkpoint. Okay, I'll wait 1 minute over here for those who need to take note. Okay, let's continue. Let's go on to the next question. Okay, predict the result when 8 blocks are put on the force meter. Okay, now you count them. See, this is about how many one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, simple. What you do, you take the most one, which is A. Okay, you count here, got 10. 10 masses, okay? So 10 masses divide by the reading, which is 10 Newton. Of course, it is common and obvious that 1 mass is equivalent to 1 Newton. So you times yourself. When 8 blocks are put onto the force meter, of course, the answer is 8 Newton or 8N. Is that clear? When the question asks for predict, you must give a certain value, okay, a certain value or a certain specific observation. Okay, all right, last question. Okay, figure 3 shows a comparison table. Okay, figure 3 shows a comparison table between weight and mass. Now, I've already asked you to do this in your exercise book, so I assume all of you should remember this by your fingertips. Okay, so now it's always weight versus mass. It's not the same thing. Okay, weight is not mass, mass is not weight. So weight is always measured in newtons. Very good. What about mass? Mass is measured in kg or g, or kilograms or grams. So this is the answer. Okay, measured in kilograms or grams or grams. Okay, the second difference is weight is always influenced by gravity, so it changes in different areas of various gravity. For example, like in the video earlier, you see Dr. Bainal said earth, what moon is only 1/6 out of the gravity from the moon, right? So same, okay, it's same because um now the weight for of you, let's say the weight of a certain person is 50 newtons, and of course it's very different when it's on the moon. Okay. Okay. The one that is comparison to this in mass is that mass will always remain same no matter where it is. No matter, even if the gravity is so different, mass is always the same. Okay. One more difference that I did not include here, but I gave you during your what is that school, I mean your class session, was weight is a force. Very good. And mass. Is mass a force, class? Okay, yes, very good. Mass is not a force. Okay, always remember, weight is a force, mass is not a force. Okay, now ask yourself, why do you think weight is a force and mass is not a force? Okay, ask yourself. Okay, yeah, force. Force is always measured in Newton. Okay, what is weight measured in? Newton. So do you see the link? You see the link now? You see, both of them is measured in Newton. So that is why weight is a force. Got it? That is why weight is a force. But mass, okay, let me clear this. What about mass? Mass is measured in kg or g. So that's why it has no link with Newton. Okay, it has no link with Newton. Thus, mass is not a force. My handwriting is bad. Okay, all right. I will stop here 1 minute for those who want to take note. If you got this table wrong, I want you to redraw the whole table again. Okay? And the topic for your exercise book, you must write correction for test knowledge week 2. Okay, I'll wait 1 good minute for all of you. All right. Okay, we are done for our test knowledge discussion. Okay, now the question still remains, we have gravity to differentiate what is, like what is weight, what is mass, and all that. But what if we lost gravity for 5 seconds? Let's watch this quick video on what happens if we actually lost gravity. Okay, check if I'm sharing sound. Okay, good. Give me a moment. Okay, enjoy.
Oh, little kitty, you can't fly like those fictional superheroes. The gravity will pull you down.
Stupid gravity.
Oh no, little kitty. Gravity isn't stupid, but a super force necessary for our planet's existence. Losing it even for a few seconds can have a devastating impact on our lives. Wait a minute. That's
Just because this video said the S word, I don't want anyone to say the S word in my class. Okay.
an interesting situation to explore. Hey friends, so in today's episode, let us see how life on Earth would be without this powerful force called gravity and answer a hypothetical question. What if we lost gravity for 5 seconds? Zoom in! So, what is gravity? Well, as we know it, gravity is a force that the Earth exerts on everything around it. This includes everything from the smallest pebbles to the tallest skyscrapers. Anything that has mass is in the grasp. Although the absence of gravity seems to be a fun situation after seeing those astronauts floating in space movies. And some of you might secretly wish for its disappearance so that you can fly freely. However, you might not want that to happen if you fully understood what would happen if gravity ever decides to call it quits, even for 5 seconds. According to the experts, such a situation would never ever occur. But for the sake of this video, and to know about the importance of this almighty force, let us assume what would happen if someone with a desire to fly decides to turn off gravity. Well, in that case, the first thing that will happen is that everything will go for a toss instantly. Yes, not only you, but also the vehicles, garbage, animals, and so on. Even the things rooted deep inside the ground, like trees, poles, buildings, etc., will not remain intact for a long time and will eventually start tumbling and rolling madly around the Earth. And as the Earth spins faster along the equator, so the impact of lack of gravity would be felt the most over there. Yes, in the middle of the planet, you could experience winds almost 6 times more powerful than the ones produced by cyclones. This means that in just 5 seconds, you could be swept as far as 2.3 kilometers in any direction, along with other objects and water from all the water bodies around the world. Simultaneously, without gravity, the Earth's atmosphere would disappear as all the gases will float up into outer space. This means that there would be a sudden and drastic change in air pressure, which would immediately rupture the inner ears of every living being on Earth. Not only that, without the atmosphere, there will be no oxygen on Earth. And without the life-supporting oxygen, those who manage to survive so far will eventually begin to suffocate, which could be fatal. How? To know more about it, watch our video, What If the Earth Lost Oxygen for 5 Seconds? The link is in the description below. And lastly, as we know, our beloved Earth itself is held together by gravity. So without this force, the pressure of the Earth's inner core will cause the planet to expand, leading to significant earthquakes and trigger massive volcanic eruptions. And as gravity plays the leading role in the Earth's orbit around the Sun, it will lose its position and start drifting in space at a speed of 30 kilometers per second, never to return to the habitable zone. In other words, it will be the end of the world for us. So it's essential not to take gravity for granted and always stay grounded. Trivia time! Did you know astronauts lose bone mass and muscle strength during stints in space? And their sense of balance changes. Also, for reasons not entirely clear, our red blood cell count falls in the absence of gravity, bringing on a form of space anemia. Hope you learned something new in today's episode. Until next time, it's me, Dr. Binox, zooming out. Never mind.
Okay, I hope you learned that, without gravity, we can't survive. Very good. Okay, now for the last few minutes of our class for this week, I want all of you to actually open up your student workbook. Okay, open up student workbook. Okay, I want all of you to finish this up today. Okay, I will put a timer of 15 minutes. 15 minutes. Teachers, can you all please do me a favor by making sure they do this homework, not leaving it by blind, because I will discuss this when I'm back later. Okay, so a 15-minute timer. By the way, thank you so much, teachers, for helping. 15 minutes. Okay, saving. Okay, so please do your homework for page 52 to 55. Okay, if you don't know, please discuss with your friends, but do not create much havoc in class and don't give teachers a hard time. Okay, class. All right, I'll put a 15 minutes timer. Please finish this up today. Okay. Okay. 15 minutes is up. All right. Okay, so this is the end of the class. If you guys have any questions, please ask me. You all know my email, which is yvonne@cis.edu.my. Okay, I will discuss this homework when I'm back. All right, take care, everyone. Thank you so much for today. Bye.